Okay guys, so we are going to solve equations using a single trig function. What I want you guys to remember is last section we learned with infinitely many solutions we were adding on a pi or 2 pi k depending on the trig function, made us do one or the other. So here's some rules that we want to keep in mind. To solve cosine or sine, you want to make sure that you use on the interval of 0 to 2 pi and then add multiples of 2 pi. So that's your 2 pi k that you add on. To solve secant or cosecant, convert to cosine and sine, and then keep that in mind. To solve for tangent, you want to solve on the interval negative pi over 2 to pi over 2 with multiples of pi. So that's our adding our pi. And for cotangent, convert to tangent. Okay. So keep these in mind as we go. I'm not going to go over the unit circle right now. Hopefully you guys have that down. And we will jump into example 1. So solve the equation of cosine 2x equals negative square root of 3 over 2. So the first thing we want to keep in mind is the square root of 3 over 2 for cosine. And in our unit circle, we have our first one is at 5 pi over 6. And our second one is at 7 pi over 6. Now, of course, with cosine, we are going to add 2 pi k to it. Now, this was just cosine itself. So really, though, we're not looking at that x equals this. We're looking at that 2x. So guys, to get to x, pretty much I took the arc cosine and found that on the unit circle. Now let's start solving. So to get x by itself, we're going to divide by 2. So we get x equals 5 pi over 12. Now multiply everything. So this is plus pi k. And then this one is 7 pi over 12 plus pi k. Now let's remember that we are looking at solutions between 0 and 2 pi, not including 2 pi. Well, let's think of the values of k that can make this happen. Well, k can equal 0, right, because we're still on the unit circle. K can equal 1 because we're still between 0 and 2 pi, but we can't go any further because if k equaled 2, we'd be more than 2 pi, so we're going to stop right there. What we're going to do now is plug in the values of 0 to 1 and we'll have our solutions. So we get that x can equal 5 pi over 12. If I plug 1 in here, we get 5 pi over 12 plus 1 pi, which is going to be 17 pi over 12. And the second one there, well, I plug in 0, I get 7 pi over 12. And if I plug in 1 for k here, I get 19. And these are my solutions. Alright, next one. Solve cotangent. 3x equals 0. So where does cotangent equal 0? Well, cotangent equals 0 at pi over 2. And then what are we doing each time to it? We're just adding pi k. And you can go back to your rules for cotangent is 2 pi plus pi k. Now, what we know is that 3x equals this value. So start solving. So we're going to divide everything by 3. So we get x equals pi over 6 plus pi over 3k. Now let's talk about the integers that we can plug in. So we can plug in 0. If we plug in 1, we're still under 2 pi. Plug in 2, we're still under 2 pi. Plug in 3, we're at pi, so we're okay there. If I plug in 4 pi, I'm still okay. And 5 pi, actually, I'm still okay. But 6 would give me 2 pi, and then we would be adding on to it. So we can actually put all of these values in, and that is what we're going to do now. So we get x equals pi over 6 when we plug in 0. When we plug in 1, we'll get pi over 6 plus pi over 3, which is pi over 2. You can do that math if you need to on the side. If I plug in 2, I get pi over 6 plus 2 pi over 3, so that's 5 pi over 6. Plug in 3, I get 7 pi over 6. Plug in 4, I get 3 pi over 2. And 5, I would get 11 pi over 6. And as you can see, 11 pi over 6 is less than 2 pi. So we know we're in the right ballpark. Okay, and those are our answers. Let's move on to the next one. Cosecant. Well, from our rules before, it says convert first. So cosecant converts the sign. So I'm going to flip this and look at sine of 1/3 x minus pi equals, and if I flip that and I get 1 over square root of 2, let's think of it as the simplified form. That would be square root of 2 over 2. Okay, that's simplified. So if you did the reciprocal there, you would get 1 over the square root of 2, but we can get rid of that square root in the denominator, and this is where we're looking. So think about the quadrants that sine is square root of 2 over 2. So that's the first quadrant and the second quadrant. So the first quadrant, square root of 2 over 2, is at pi over 4. And the second quadrant is 3 pi over 4. Well, there's no connection between these two, so we're going to have to deal with two different equations. So we have plus 2 pi k for each of these. It looks like I didn't leave myself much room, but we have to keep in mind that this equals the 1/3 x minus pi. And now we're going to solve. So I'm going to add pi to both sides. So let me arrow this so you guys know what I'm doing with it. I'm going to add pi to both sides. Now, think of this, though. When you add pi to both sides, you can't add it to the 2 pi k. You have to add it to the pi over 4 and the 3 pi over 4, okay? So, when we add the first one, we get 5 pi over 4 plus 2 pi k. And if we add a pi over here, we would get 7 pi over 4 plus 2 pi k. Huh? Not underlined. Okay. Now, we have to remember and keep in mind that this is still 1/3 x. Okay, how do we get rid of a 1/3? We have to multiply both sides by 3. Alright, so we have to multiply everything. So we're going to get 15 pi over 4 plus 6 pi k. And we get 21 pi over 4 plus 6 pi k. Now let's look what values of k would still allow us to be between 0 and 2 pi. Okay, let's put in 0. If we put in 0, wait a second, this is like 3 pi. It's over, right? Both of these are over. If we plug in 0, both of these are over 2 pi. So there are no values that lie between 0 and 2 pi. So this is no solution. Again, it is no solution because when we plug in even 0, this is above 2 pi. We only want to be between 0 and 2 pi. Alright, solve secant squared of x equals 4. So the first thing we're going to do, guys, is take the square root. Get rid of that square. So I get secant x. When we take the square root, we get 2. But when we also take a square root, we get plus or minus. Now we're going to convert it into cosine. So I get cosine x equals plus or minus 1/2. We can think of this as a couple ways. We know it's on the unit circle, so we can look at all of our 1/2s, or let's look at it like our equations, right? So cosine of 1/2 is pi over 3. And what we're going to do each time with this is add pi k to it. Right? We add 180 degrees to be able to get to the next one. And then we have 2 pi over 3. And we can also add pi over k. What are the only values of k that keeps us in between 0 and 2 pi? Well, k can equal 0 or 1. So when we plug that in, we get pi over 3, 4 pi over 3, right? Because if I put 1 in there. Now let's end the second one. I put in 0, I get 2 pi over 3. I put in 1, I get 5 pi over 3. Now really we could have done that just by looking at the unit circle and doing cosine of 1/2 plus or minus 1/2. These are a little bit trickier up here, so you need to do the algebra out. Alright, next one. So we're going to solve using inverse. So you need to have your calculator. We're doing inverse because these points aren't obvious on the unit circle, so we're going to have to use our calculator to help us, okay? So, first thing we're going to do with tangent, if you look at your rules, right, for tangent, there we go, it's multiples of pi. So whatever we get, we're just going to add pi k onto it. So here, I get, to get rid of tangent, I can do arc tangent, because I don't know what arc tangent of -3 is. Okay. We didn't have to write that down before because our values lie down the unit circle, so it allowed us to kind of not think of it. Now, we know that with tangent, though, we're adding pi k to it each time. I have to put that pi k before I do my solving, okay? So when we do arctangent, you just add pi onto it. So we're going to multiply both sides by 2. We get 2 arc tangent of -3 plus 2 pi k. So the only values that keep us in between 0 and 2 pi is k equals 0. So what we are going to do with that is then use our calculator. So we're saying 2 arc tangent, because that is on your calculator, guys. Sorry, mine is glaring. Of -3. And then you could say plus 2 pi times 0, but other than that, it is okay. Alright guys, I made a mistake here. Because if we use our calculator right now and all of a sudden we plug in 0 for k, you get -2.49 blah blah blah, right? Well, it has to be between 0 and 2 pi. So let's erase that. It can't be 0, so let's try 1. Maybe 1 will give us a better value. When you plug in 1, we get 2 arctangent of -3 plus 2 pi. So put that in on your calculator. Maybe you guys can see that now. I know it's kind of blurry. There we go. And then our answer is 3.7851. Okay, so even though it seemed that our k would have been 0, we need to keep in mind that when we plug it in, it's a negative. It's not on our interval. Okay. All right, one more. So here we get sine of 2x equals 0.87. We're going to use our arctangent again to solve, because specifically we do not know this value. So arc sine of 0.87. And we learned that in the last section, when we do arc sine, we actually have 2 values we need to look at. We need to look at this equals 2 pi k. But the other one, if you look back at last section, we actually, because we are in the third, or the second and the third, right? To get that third quadrant, we had to say pi minus arc sine of 0.87 plus 2 pi k. That's how we got around for our 2 values of sine. Now this is 2x should equal this. So how do you get rid of the 2? We have to divide by 2. So in the first one here, we get x equals 1/2 arc sine of 0.87 plus pi k. And in the second one here, we get x equals pi over 2 minus 1/2 arc sine 0.87 plus pi k. Alright, let's talk about the values of k now. We assume that k can be 0 and 1, and once we plug those in, we'll get our answer, and we are all set.